thank you so much for joining me. In this segment, I want to do a few application questions regarding the pH scale. We will get into calculations of pH and POH in another video clip. This is more the qualitative understanding of a pH scale. So in this case, I have two separate beakers. So I have a beaker with a pH of 4, and the second beaker is a pH that is unknown. So when I mix these two together, I end up with a beaker that has a pH of 5. What can we say about the pH and hydroxide concentration of the second in comparison to the first? So if you look at your pH scale, we've got 0, up here is 7, and so 1, 2, 3, 4, 5, 6, not very to scale, but you get the idea. So I start at pH 4 and I end at pH 5. What this means is I have increased somehow my concentration of hydroxide relative to my H+. Now to do that, I have to add a solution that's greater than where I ended, because we're going to mix the two together. So my beaker, in fact, was likely pH 6. Okay, assuming equal volumes, if I added pH 4 and pH 6 together, I'm adding enough extra hydroxides to raise my pH. Okay, so that would be one type of qualitative problem you have. Now, my husband and I have to deal with this quite a bit because we have to monitor the pH of our spa. So we have a desired pH of 7.5. Okay, and what this is not ours, but in this example, what they're saying is my actual pH is above 7.5. So it's currently above 7.5, and I need to move it down towards 7.5. Well, if I'm making my pH go down, that must mean I have to increase my relative H3O+. Because remember, as you increase H3O+, you will decrease your pH. So I want to add an acid to my solution, something with more H3O+ in order to drive it down. Okay. Now, in this next one, I've gone from pH 4 to pH 6. What has happened? What is the change in hydronium ion concentration? Well, you can either memorize that every time you change your pH by 1, so that's a factor of 1, you change your H3O+ concentration by a factor of 10. Okay, so in this case, if I'm increasing my pH, the first thing you need to know is that you're decreasing your H3O+. Okay, so that's what you would want to know first. Now, 10 times 10, so if I'm changing by a factor of 2 here, so a change in, whoops, I grabbed highlighter instead, sorry about that. A change in pH of 2 would mean a change in H3O+ of 100. Okay, 10 times 10. And in this case, it would be an increase in pH means a decrease in H3O+. You might want to see these numbers, 1 times 10 to the minus 4th. This is 1 times 10 to the minus 6th. I think that makes it very clear that it's a decrease of 100 times. Okay, so hopefully these little this little short clip has helped you on the qualitative aspects of the pH scale. Thanks for joining me. Have a great day.